Have you ever wondered why an apple falls straight down from a tree and not sideways or upwards? Or why does a rolling ball eventually come to a stop? These daily life activities are governed by the fundamental laws of physics. At the heart of these phenomena is the concept of force. Force is something that can cause a change in the motion or shape of an object. It's the invisible hand that shapes the world around us. So let's dive in and understand the fundamental laws that govern these phenomena. You've probably heard of Sir Isaac Newton, the man who formulated the laws of motion. Let's take a closer look at these three laws and see how they apply to our everyday lives. First up, Newton's first law, also known as the law of inertia. It tells us that an object will stay at rest or move in a straight line at a constant speed unless acted upon by an external force. Think about when you're pushing a shopping cart. It doesn't move until you apply a force, and it continues to move until you apply another force to stop it. Next, we have Newton's second law. This law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So if you're in a car and step on the gas, the car accelerates. The harder you press the pedal, the greater the force, and the faster the car accelerates. Finally, Newton's third law, often summarized as, for every action, there's an equal and opposite reaction. This is the reason why a gun recoils when fired. The bullet is propelled forward by a force, and an equal force pushes back on the gun, causing it to recoil. These laws help us understand how objects move and react under different forces. There are various types of forces that we encounter in our daily lives. Let's take a closer look at some of these forces. First off, gravitational force. This is the force that keeps us grounded, quite literally. Then we have the normal force, which is the force exerted by a surface to support the weight of an object resting on it. Think of a book resting on a table. Next is frictional force, the force that opposes motion. This is why we need to exert effort to push a heavy box across the floor. Spring force comes into play when springs are compressed or stretched. Ever noticed how a spring bounces back when you let go after stretching it? Electric and magnetic forces are also quite fascinating. These forces govern the interactions between charged particles or magnetic objects. Lastly, we have centripetal force, which is responsible for keeping an object moving in a circular path. Each of these forces has its own unique characteristics and formulas. Now, how do we apply these laws and concepts to solve real-world problems? Let's break it down step by step. First, we start by drawing a free body diagram. This is a simple sketch showing all the forces acting upon an object. Let's take, for instance, a car moving up a slope. The forces acting on it would be gravity, normal force, friction, and the force exerted by the car's engine. Next, we choose a coordinate system that aligns with the direction of the object's motion. In our car example, the x-axis could align with the slope, and the y-axis could be perpendicular to it. Then we formulate force equations for each axis based on Newton's second law. Remember, net force is equal to mass times acceleration. On the x-axis, the net force would be the force of the car's engine minus the forces of gravity and friction. On the y-axis, the net force is zero, as the car isn't lifting off the ground or sinking into it. Lastly, we solve these equations to find the variable we're interested in. In this case, we might want to find out how much force the car's engine needs to exert to move up the slope at a constant speed. With a good grasp of these concepts and formulas, you can analyze and solve a wide range of physical phenomena. So that's a quick tour of some fundamental concepts in physics. We've looked at the concept of force, Newton's laws of motion, the different types of forces we encounter every day, and how to apply these laws and concepts. These aren't just abstract ideas, they're part of our everyday lives, helping us understand everything from why we don't fly off a spinning roundabout to how a car accelerates. Remember, physics is not just a subject, it's a way of understanding how the world works around us.